So we left off finishing the table here. We haven't done example 9 yet. So you can figure this out based on the table, but I think it's probably just as easy to graph and just kind of double check that what you're graphing makes sense. All right, so we want to do 5 cosine of 2 theta. So just a quick little inventory. How long should the leaves be? How many leaves are there going to be? And then is this going to be on the x-axis? Or is this going to be on the not on the x-axis? So leaves should be 5 units in length. This should start on the x-axis, and there should be, because that's even, 2 is even, we should have actually 4 leaves. And so when we graph it, yep, that's what we got. So I'm going to try to sketch this thing. So my first point is at the origin. Then I'm going to go out to a distance of 5 on the x. And I looked at all the rest of those. They'll be moving along the same way. And then just try to do the best you can. I really recommend just draw and just keep going. Not great, not too bad. All right, let's take a look at 4 sine of 5 theta. The only reason I need my calc here because I don't really know exactly what angle those 5 things will be on because it's not going to start on the x-axis, so it's a little bit tougher to draw. Alright, so we got an idea there. Try to sketch it over here. So I know they're going to be 4 units in length. It looks like my first one, I'm going to swap these around so I can use my right hand. Alright, so this is, I don't know, 1, 2, 3, 4. It's somewhere in here. And then looks like it's right on top. And somewhere over there again. And somewhere down here. I don't know if those are at 30s and 60s exactly. I don't think they are if I remember. I think I've looked into that before. But it takes that, no, yeah, there's no way. Because it would, well, yeah, because this would only be 60. And then from there to there would be 90. So that's too far to go. All right, now you want to just try to connect these with, start at the origin, and then once you start going, just keep going. Yeah, not my best, but okay. All right, now let's see if we can write an equation. I would recommend that you try to pause here and try to come up with the equation on your own. All right, let's see how you did. So the first thing I'm going to decide is how long the leaves are. So 1, 2, 3, looks like a distance of 4. So my equation is going to start off with a 4. Did it start on the positive x? Nope. So that means it has to be a sine. Remember, all we're doing is the equation for a rose curve is a sine or cosine and then n theta. N is the number of leaves, a is the leaf length, sine and cosine is which axis they kind of appear on. So we noticed that it was on the y. It was 4, and then we have 1, 2, 3, 4, 5, 6, 7 leaves. So 7's an odd number, so that means I want to have 7 in my equation. That's supposed to be a theta. Not a very good theta, but you get the idea. All right, pause. Try to do the next one on your own. Let's see how you did. So now I want to do color. Let's do a blue. Let's do brown. All right, so leaf length is 5 again. Oh no, last one was 4. Leaf length is 5. This time it does start on the positive x, so it's going to be a cosine. Let's see how many leaves there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's an even number. So that means that the number that in front of theta must be 6 because we're going to double it when it's even. All right, so hopefully the regular rose curves kind of make sense. Now we get into the coolest ones. Well, not as cool as these down here, but the coolest ones that you could be held to try to draw on your own is the fancy rose curve. So a couple of things to highlight right off the bat. Very similar again. So if cosine is on the x, sine is not on the x. The long leaf. Oh, okay, sorry. We haven't talked about long leaf versus short leaf. Over here we just talked about leaves. So let's look at one of these. Let's just do it on our calc. I was going to go back to Desmos, but... Alright, so we want to do 1 plus 2 sine of 4 theta. And we get this sort of rose curve again, but some of the leaves are longer and some of the leaves are shorter. That's actually, I think I'm going to try to do this on Desmos. So we have, notice the difference between a rose curve and a fancy rose curve. A rose curve just has something like, say, 2 sine of 4 theta from 0 to 2 pi. And so a regular rose curve is just a coefficient, then a trig, and then you go from there with the number of leaves. To make this into a fancy rose curve, we put the 1 plus out in front. And so we still have the characteristics of leaves. We still have, if it's an even number, you're going to have twice as many leaves. If it's not, it's going to be the same number of leaves. Let me just prove that to you real quick. So, oh no, that's right. I forgot about this. That there always doubles in this case, and that's because we have long leaves and we have short leaves. So a fancy rose curve has 2 different kinds of leaves. Now, if you remember, when we talked about when this was an odd number, I said that the leaves actually, there were double leaves, but the second set of leaves was exactly on top of the other. Well, that's still true. They're exactly the same angle, I should say, but they're not the same length anymore. So now we have a long leaf and a short leaf. So let's take a look. Let's see if we can figure some things out here. How long is the long leaf? Looks like it goes to 3. Look over here, see if you can figure that out. How long is the short leaf? What a coincidence. This ties back to what we did before. Pause it and try to come up with a plan. What do you think the relationship is if I change this to a 2 and a 4? What's going to happen to the big leaf? What's going to happen to the little leaf? Well, hopefully you figured out the big leaf, the long leaf, is 6. The little leaf is 2. So now we've got a pattern here that we can go back and put into our notes. But I like these the best. These are some pretty cool graphs you can make. Let's go crazy. Let's do like 23. Oh, much. 24? Even crazier. All right, anyway. Oh, that's called a lemniscate. Lemniscate? Lemniscate, something like that. All right, anyway. Let's go back to our little table here. Fill in some of these details. So we now have the long leaf. The long leaf is found by taking these two numbers and adding them together. B plus A is the long leaf. B minus A is the length of the short leaf. And then when it comes to the number of leaves, this time it's always there are always 2n leaves. So whatever n is, there's always going to be twice as many leaves. Okay, so I would recommend trying to pause here and trying to sketch these and see if you can do it. I would probably use a calc. It's just to double check. You probably can get a pretty good idea. All right, let's see how you did. So I'm going to go 1 plus 2 sine of 4. Oh, that's the one we just did. Okay, so my long leaves are at an angle off of it, and my short leaves, so I would say something, I don't know, something 3, 1, 2, 3, maybe here and here. Let's say here and here. That wasn't a very good one, was it? Here and here. Let's say here and here. Say here and here. And then again, when you draw this, just keep going. So big leaf. big leaf, big leaf, big leaf, little leaf, little leaf, little leaf. Ugh. Like I said, I'll give you the benefit of the doubt because I can't draw them very well either. All right, pause. Try to do the next one on your own. Let's see how you did. All right, this one's a lot easier because when it's cosine, it starts on the x-axis. Sine, it just doesn't start, but it doesn't always hit the y. Sometimes it does. These will always hit the x. So this is going to start off my origin, and then my big leaf is going to be 6. And then we're going to go... They look a lot nicer on Desmos. That one doesn't look too bad. Alright, so my next angle is going to be a 5. I don't think it's at 60. I'm going to go a little bit closer. I'm going to say somewhere around the 45. Somewhere around the 45 and somewhere a little bit past the 60. And then we have a short leaf of 4. So here at the same angle. Smaller radius. Alright, so big leaf. Now into the little leaves. Anyway. Ugh, it looks awful. Whatever. Close enough. I'll give you guys the benefit of the doubt. Alright, let's see if you can now figure out some equations for these. Pause. Give it a try. Alright, let's see how you did. So I need my big leaf to be 6 and my short leaf to be 4. So the two numbers that add to make 6 and subtract to make 4 are 1 and 5. So I know this is going to be 1 plus 5. Alright, it didn't hit the positive x, so that must be sine. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so that's got to be 6 theta. And then our last official example, the rest of them are just things that I think look really cool. So my big leaf is 6, my little leaf is, what, is that 2? 6, 5, 4, 3, yeah, 2. So add to 6, and that's 2 and 4. I got to add to 6 and subtract to 2. So 2 plus 4. This time it did start on cosine. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's 7 theta. Alright, so I've got about 2.5 minutes left. I'm just going to show you over on Desmos those graphs at the bottom. If you want to type them in, it's up to you. I've already typed them in for us, so let's take a look. So the first one is just r equals theta. Kind of cool. It's a spiral, especially if I try to zoom out. You can see that thing now. I would go here and I would change this. This was said 12 pi. Let's say I make it 32 pi. I get more and more and more of it. You're possessed. All right, that one's kind of cool. This one I think is cooler. This is called a logarithmic spiral. This one's called the Archimedean spiral, or spiral of Archimedes. Notice how it goes out by the same ring each time. It goes the same distance. But the spiral of Archimedes, the logarithmic spiral, the gaps keep getting bigger and bigger. So I'll go to 32 pi again. And so you see how the rotations get bigger, so I can zoom. Anyway, pretty cool. And then the last one, I really like the last one. This is the one that I saw as soon as I saw it, I tried to graph it on my calculator. This is called the butterfly curve, as you can obviously see. Pretty cool. You can see the little face right there, a little smiley, his beautiful wings, or her. I don't know what the butterfly is, but butterfly curve. So a couple of cool graphs. I've got them at the bottom. You can set your windows. Set up your window underneath each graph. I told you what a good window would be to make that picture. So anyway, all right. Well, that's it.